Hi everybody. So for this video, what I'm going to do is I'm going to make use of this website, this GraphFree.com. Uh, Hopefully it's not considered something commercialized, as the version I'm using is free to the user, and I actually use this to create some exams and some now. So I'm going to use this to demonstrate how to do transformations and reflections using quadratic equations. So what we're seeing here is that here we see f of x equals x squared. Okay, so that's a graph of what I call the base parabola. So here's your base parabola right here, and notice where the vertex is. It's located right here at the origin. Okay. By the way, this is part one of probably a two-part video, maybe more, that I'm going to talk about reflections and transformations when it comes to graphing. And I'll just try to make these about 5 minutes long tops. This one, I'll go ahead and use this GraphFree.com feature, but on future videos I'll probably go ahead and show myself actually physically doing these on the board, okay? Alright, so like I said, this is our base graph that has this vertex at the origin. Now let's see what's going to happen if I say do x minus 1 quantity squared. Let's see what that does to this graph, okay? Ah, it moved it to the right. Well, that's interesting. Okay, so how about x minus 2 quantity squared? Let's see if you're going to guess that it's going to go to the right yet another one. Oh, you're correct. Well, all right, then what if it's a plus, addition sign symbol? That's going to take the base graph, and if you guess that it's going to take my base graph and take it and move it to the right 2 units, you would be correct. So the way to think about this is a couple ways you can do this. One way you could do is think about it this way. Whatever you're seeing inside the parentheses getting added or subtracted to that x is probably the opposite of what you would think. So if it's x plus 2, you would think it moved to the right. It's actually moving to the left. Okay. Another way you could think about this is you could just take that x plus 2, for example, and set it equal to 0 and solve for x. You would get x equals negative 2, right? Negative 2 being that point right there. Okay, well, now let's take a look at what would happen if I added a 1 again, but this time not in parentheses. It's going to take the base graph and it's going to move it up to here, right? So remember, if the base graph had its vertex at the origin, you added a 1, it moves it up. And if we say went minus 2 or something, whoa, I won't go that small, minus 2, it moves it down. So to summarize that little comment, whatever you're seeing getting added to or subtracted from whatever's getting squared there is going to be exactly what you think. So if we got a minus 2, it's going to take your vertex or your whole parabola and shift it down 2 units. If it was like a plus 2, it would move it up 2 units. Okay, so now let's see what would happen if we had a little bit of both going on. Oh, come on. So let's say maybe x minus 3 quantity squared, and maybe go plus 4. So you would think it would take from and you can use the vertex as your reference point. It's going to move it to the right 3 units, 1, 2, 3, and then up 4, 1, 2, 3, 4. So our vertex is going to be here at the point, 3, 4, and then it's going to flare out accordingly, like that. Okay, now let's take a look at what happens if we say, well, let me just take our base graph again, okay, and let's see what happens if we double it, just like this. Just take 2 times the entire graph. Makes it skinnier. So one thing that I like to tell people is it's kind of like using the slope. So from the vertex, you could call this like 2 over 1, this 2 right here. And from the vertex, you can go up 2 over 1 to get you that first point on either side of the vertex here. And notice we've got what's called an axis of symmetry coming right down through the middle of this graph, where half the graph will be on one side and half the graph will be on the other side, okay? So if we make this number in front of x bigger, the bigger it gets, the skinnier this thing gets, okay? Well, what's going to make this thing thinner? Well, what's going to make it thinner is a fraction. Okay, so 1 over, say, 9, that's going to make it really fat. Okay, so the bigger your denominator, with a 1 in the numerator, and then just the bigger number in the denominator, it's going to make you get fatter and fatter. If you're curious as to what's going to happen if you do, say, 2/3, it just alters it accordingly. Okay, 2/3 of 1, it's going to be a little smaller than 1, which makes it a little bit fatter. Okay. Okay. This graph's gone plenty long, or this video's gone plenty long enough, but I want to show real quick reflections. If I put a negative in front of my x like this, that is going to make this graph flip upside down. Okay. And that's pretty much all there is to it. Go ahead and take a look at my second, maybe even third videos. I might make a few of these to show how these reflections work, and I'll do them on the board without the use of technology in the sense of a graphing tool like this. Thanks for watching.